Hello everyone. In our freefall lab and beyond for the rest of this unit, we are going to be looking at objects which we will call projectiles. Now as you see here, a projectile is an object for which only gravity is acting, right? Nothing else. Air resistance is either so small we can neglect it, or as we talked about in freefall, maybe we're in a vacuum, right? And therefore there is no air resistance. This is not when you're throwing something. This is not after you're catching something. This is while it is moving on its own, all right? While it is a projectile. So whenever we talk about projectiles or projectile motion, right, we're going to be talking about only gravity acting, okay? Specifically, no air resistance is usually the big one that gets in the way. And that sometimes has some interesting consequences. For example, as we saw in the last lab, all objects fall with the same acceleration regardless of mass in a vacuum if we can neglect air resistance. All right, so we get Galileo's law of falling bodies. So we did free fall. Right? The next thing we're going to do here as we look at projectile motion is kind of take it to that next step. So projectiles, we've seen projectiles in terms of like free fall, if we can neglect air resistance in all of these. But an object that's thrown up in the air and goes straight up and comes straight down is also a projectile, at least after he's thrown it and before he catches it or it hits the ground. And something that's thrown at an angle and travels in this full parabola is a projectile. After he throws it, before it hits the ground. And so these are all different kinds of projectile motions, more and more complex. And that's kind of how we're going to build things through this unit here too, right? Starting with free fall that we've already done, and now up and down, one-dimensional projectile motion, as you notice the title is here, and then we'll get into two-dimensional projectile motion in the back end of the unit here, right? We'll do some, when we get to here, we're going to do some hands-on labs in class, as well as another pivot. So today's pivot is actually the video that we used before, except instead of only measuring it on its way down, we're going to look at it on its way up and its way down and see what we can learn about that motion, which I am going to call one-dimensional projectile motion. 1D means one-dimensional, right? One-dimensional projectile motion. So I know in the picture it goes a little bit to the right, but that's because otherwise it would end up overlapping. So this is straight up and straight down, right? Usually how we draw it. Okay, so that's what we're going to look at in this lab. So if you remember the video, okay, let's watch a couple of things about the video on how we're going to do this lab. And all of these steps are, of course, written both in the pivot and on your lab sheet. So we're going to go over and turn on the vertical rulers to help us make a little more precise measurements. All right, turn on the stopwatch, move it over a little bit. Now, we're not going to do this on all 5 balls or even 4 balls like we did with free fall. We're just going to use the green ball here, okay, as the only one. And we want to start it from the instant it leaves the hand. See how that's the instant it leaves its hand? And then that is when we will zero the stopwatch. That means everything after this we can assume is free fall. Yes, there's a little air resistance, but we can neglect it because it's very little, it's not moving very far, and it's a nice small round ball which is heavy for its size. It's not like the styrofoam ball over here that kind of falls behind because it's so dang light. All right, so we'll measure it on its way up and on its way down. We're going to take measurements every 0.05 seconds like you did in the last lab. And like the last lab, you're going to measure the bottom of the ball every single time, right? So always measure to the bottom of the ball, because if you notice when it was at the top, the bottom of the ball is at 0. So we will get a wonderful position time graph that will be all the way up and all the way down, right? And then we can turn that into a velocity time graph, and then from there we can examine the acceleration so that we have a full picture of the motion of a one-dimensional projectile.